Hi, welcome to today's notes. We are going to be talking about finding volume and comparing volume. So a little bit more with the story problems. Go ahead, have your volume formula sheet out so you can follow along with that. Make sure that I'm doing everything correctly here on today's video. So let's go ahead and get started with number one. Number 1A, given the following figure, find the volume, and we're going to leave it in terms of pi. So let us remember what shape this is. This is a cylinder, so we're going to write down the formula for a cylinder. It is V is equal to pi r squared h. We'll have r equals 6, and the height equals 3. V equals pi times 6 squared times h, which is 3. And let's go ahead and simplify this and solve. So we have 36 times 3. 36 times 3, the volume here is 108 pi inches cubed. Okay? So that's what we have for this cylinder. Part B says draw a cone with the same dimensions as the figure in Part A. What is the cone's volume? We're going to leave it in terms of pi. So drawing a cone. And so I have a radius and I have a height. So my radius is 6, my height is 3. Okay? Let us write down the formula for this cone. This cone is 1/3 pi r squared h. And I have 1/3, so we're going to substitute. My radius is 6, my height is 3. And now we're going to go ahead and simplify and solve. I have 1/3 pi times 36 times 3. And then I know that 36 times 3 is 108 from the previous problem. And then all I have to do now is 108 times 1/3, or 108 divided by 3, I know is 36 pi inches cubed. Okay, so something, oh, you know what? I'll talk about it in C. Okay, so for Part C, it says, how do the two volumes compare? So there's different ways of comparing. So we can talk about finding the difference. We can talk about how many times one is bigger than the other, etc. So for this one, you know, one way that I'm going to compare this is 108 divided by 108 pi, divided by 36 pi. Our pi's do cancel out, so 108 divided by 36 is 3. And then let's go ahead and write down that the volume of the cylinder is 3 times the volume of the cone. I just noticed I'm writing everything in cursive. One of my sons, Anderson, is learning cursive in school right now, so we're doing a lot of cursive at home so he can, you know, learn to write it and read it. So for C, what I want to ask you guys, oh, sorry, slipped. What I want to ask you guys and talk to you about before we jump to number 2 is that the cylinder is 3 times the volume of a cone, okay? This is very important. The other thing, too, is you think about how many times will it take a cone to fill a cylinder with the same radius and same height. So you should think, okay, well, it'll take the cone 3 times to fill that cylinder, okay? That's important, and I'm telling you right now in the video and hoping that you'll hear it and listen to it. Rewind this if you need to, because I'm not writing it down on purpose, okay? Let's go ahead and do example number 2. Number 2 says, what would have a greater effect on the volume of a cone? Doubling the radius or doubling the height? And there are lots of different ways to figure this out. And so that is to, you know, come up with some example problems. So let's go ahead, and so we'll do one where I have the radius is 5 and the height is 2, and we'll do the same thing for our other cone. And so you think about the formula, volume equals 1/3 pi r squared h for both. If I go ahead and double the radius, so my radius is 5, and I double that, that would be 10. So 10 squared, oops, times 2. My other example, doubling the height, my height is 2. And you think about, well, I double my radius and then it's still going to get squared versus I double my height and nothing else happens to it. Okay? Hopefully you see, well, by doubling my radius and then it still will get squared, right here I will have a greater effect. Okay? So we'll go ahead and say doubling the radius. Will have a greater effect. And I'm going with the knowledge that you guys have, your math sense that when you double and square will have a greater difference than if you just double alone. All right, let's go ahead and flip our notes over to the back. And we will talk about an ice cream shop. An ice cream shop designs a new ice cream cone. He wants the volume to be about 240 centimeters cubed. The cone is 14, so I'm going to underline volume. The cone is 14 centimeters tall. What is the radius to the nearest whole number? So if the volume is about 240, we know the height is 14. We're going to solve for the radius. So I'm going to go ahead and make my substitutions. I have volume is 1/3 r squared h. This is the formula that we're going to be utilizing. I'm going to substitute 240 in for my volume. I'm going to leave that 1/3, leave the pi. The radius is what I'm solving for. My height is 14. Okay. What I'm going to do for my next step is I'm going to go ahead and multiply 1/3 times 14. And that gives me 14/3 pi r squared. Now the reason I did that is to solve for r. Now all I have to do is multiply both sides by the reciprocal, and the reciprocal is 3/14. And when you are doing the work, you don't have to show this step of doing 14 times 1/3. You could just right here in this previous step multiply both sides by the reciprocal. Okay, and so 3/14 times 240, when you put this into your calculator, you will see that it is doesn't go in evenly. We're going to rewrite it as a fraction, so 51 3/7. Okay, we're not going to have any repeating decimals here, especially when we're talking about volume, a measurement. My next step is I'm going to go ahead to keep solving for r, divide by pi. And so when I divide by pi, I'm very close to 16, so right around 16. Okay, and now I have it set equal to r squared. Well, we know the square root of 16. Remember, we are finding the square root because that's the inverse of squaring. The square root of 16 is 4. So the radius of the ice cream cone is about 4 centimeters. Now let's move to across to the next one. We have the volume of a golf ball is about 41 63 centimeters cubed. What is the radius of the golf ball to the nearest tenth? Okay. I noticed right away that they don't talk about height, So I had to reread and think about, oh, what are they talking about? They're talking about a golf ball. A golf ball is a sphere. So we're going to go ahead and write down the formula for the volume of a sphere. So 4/3 pi r cubed. Okay, and let's go ahead and make our substitutions. So for volume, I'm going to go ahead and substitute 41 and 63/100ths in. This is about equal to 4/3 pi r cubed. That's what we're going to solve for. So we have to get r by itself. So the first thing, we're going to use the previous problem to help us, that we are going to multiply both sides by the reciprocal of 4/3, which is 3/4. Okay. It doesn't go in evenly. This problem does start with a decimal, so even though in the last problem I said no repeating decimals, we're going to go ahead. This is not a repeating decimal. Okay, let me just show you here real quick with the calculator, where 41 and 63/100ths times 3/4. Okay, I'm going to write down this whole entire decimal. Okay, we're not going to round until the very end when they tell us to. Okay, so I have 31.2225 is about equal to pi r cubed. To keep getting r by itself, we're going to divide both sides by pi. And so I can come over here and show you we're going to divide by pi. Okay, and we'll go ahead and write this down. This one, we'll go ahead and round a little bit. So 9.384 is still equal to about r cubed. Okay. The last step is to solve for r. And so remember, we're going to be doing the inverse. So instead of finding square root, we're going to do the cube root. Okay, we did cube root back in January, so we're going to find the cube root. To do cube root with your graphing calculator, I want to remind you have to hit math first, and then it's right there. You just look down and you'll find to the third power. On these calculators, you have to hit second, you have to do 3, sorry, and then second, and then this button right here, this one. So that 3 goes in for x for cube root. It was 9.9384. Write down what I wrote. And it says round to the nearest tenth. So we will say the radius of this golf ball is about 2 1/10 centimeters. Okay. And the radius is about 2 1/10 centimeters. Okay. We have a review problem with Pythagorean theorem. Tim is in a hot air balloon that has just been taken off, and is floating above its launching point. Kate is standing on the ground 16 meters away from the launching point. If Tim and Kate are 20 meters apart, how high up is Tim? So what we're going to do is we are going to go ahead and kind of draw some pictures to figure this out. So like I said, it starts, Tim is in a hot air balloon. So I'm going to just draw that first. So here is my hot air balloon. I know it kind of looks more like a boxing glove in a sense. It's floating above its launching point. Kate is standing on the ground 16 meters away. Okay. So we'll mark that this is Kate. So Kate and Tim are 20 meters apart. We want to know how high up is Tim. Okay. So that is kind of how we would set this one up. I think this part right here where Tim and Kate are 20 meters apart, that kind of throws a few people off. So just, like I said, an example problem. We write down the Pythagorean theorem formula. A, we can go ahead and label as 16. B will be our unknown. C is 20. So 16 squared is 256 plus B squared equals 400. To keep solving for b, I'm going to subtract both sides by 256. I have b squared is equal to, when I subtract, I get 144. The square root is 12 meters. All right, so Tim is 12 meters up in the air. That's it for this video, and then you'll get the rest of the class time when I see you next to work on a worksheet about comparing volume story problems, and some review with this Pythagorean theorem, okay? Help you guys get ready for that test, which is a few more days away. All right, thanks guys. Over and out.